students join this session. Okay. By the way, what's happening? Do you experience some problem in internet in Iraq? Do you have problem connecting to the Dawn website? Because all of you were late, and also many students haven't joined yet. Okay, so let's wait for a few more seconds and then we will start. Okay, then let's start. Hello again to the students who joined us now. As I recall, uh, I I told you some introduction about testability. Okay, and now first, if you have any question from previous session, I will try to answer those, and then we will start from this point. Guys, do you have any question? Is there anything you want to ask? Okay. Okay. So, as I recall, I told you the basics of testability. Yes, but I review these basic concepts to have a fresh start. So, what is testability? You know, guys, testability is refers to this particular feature of the software or the system we design that enables us to find the faults, to find the hidden faults. Okay, better saying hidden faults during testing. So testability, as you can see here, is referring to the ease which the software can be tested, and it can demonstrate its faults through these testing. So we are not talking about testing here. We don't talk about software test. Okay, we are talking about testability. How easy is it to find defaults, to perform tests? Okay, testability. So, as you can see here, we can say that testability refers to the probability, assuming that the software has at least one fault, it will fail in the next test. So, look, guys, we know that there is some faults inside our software, inside our program, and we want to find those faults. And testability is this ability, is this probability to reveal those faults during and through testings. Okay, so we can say if a fault is present in a system, then we want that fault to be found or the system to fail as quickly as possible, because when we find these faults, we can remove them. This is important. Let me highlight it for you. This is important. We want to fail, to suffer, to be failed. Why we want our software to fail? Because when it fails, we can find the causes, what makes it fail. Then we can resolve that problem. We can upgrade our system, update our system. We can fix those faults, and then our system will not fail again. So if there is a fault in the system, we want that fault to be activated and to cause system to be failed as soon as possible, because this help us to find these faults and remove them from the system as soon as possible. And it causes it poses less expenses on the team, on the project. So this is testability. Guys, I think that some of you may be asking from themselves why you want your software to be failed, or why do you want your software to fail? I told you, because if it fails in our hands when it is in the development stage, when it is in testing stage, then we can fix that, fix and repair those faults. But what will happen if we ship the software to the customer and customer faces those failures? That will cost us a lot. Okay, so if the system fails when it is in our hands, then we can fix it, we can repair it, and we can find the causes and repair those causes and eliminate those faults. Then our software will be more stable. So it's much better. Okay. So please, everyone, please read this small paragraph. Read this small paragraph. Okay. Look here, we are talking about testability more specifically. Look, if we want to be a system to be more testable, then we should be able to control the inputs and observe the outputs. So we need two things. We need two things. One, control the inputs. Second, observe the outputs. So we want these two things: to control the inputs and to observe the outputs. These two things together means a better testability. Okay, so when we say that for example, this software is testable, it means that first we can control the inputs we give to the system, and then second, we can observe the outputs we receive from the system. So let's continue. So please, everyone, please read this this row. Please read this row. Okay. As you may recall, I told you that we use this general scenario template or general scenario table to write our concrete scenarios for our project. So we should be able to read these general scenario tables, which we have at the beginning of each section in your book. Each section related to software quality attributes, we have these general scenario tables, which helps us to write the concrete scenarios. Okay. So what are the sources of stimulus for testability? Unit testers, integration testers, system testers, acceptance testers, and also the end users, me and you, end users, either running tests manually or using automated testing tools, or even using this software. So let's review this important thing here, the important row here. What is, can anyone tell me what is unit testing and how it differs from, for example, integration testing? Can anyone tell me? Unit testing versus integration testing. What is the difference? Consider you are in an interview, job interview, and you have a master degree or a bachelor degree in computer engineering, and they ask you, okay, tell us about testing. You know, it's so important. Testing is very important. What is unit testing and how it differs from integration testing? What will you say? What will you say? Can anyone tell? Nobody? Okay, when you are creating your, developing your program, creating your software, you need to perform different levels of testing. Okay, we will have another course related to these concepts. Maybe next term, next semester, next term, I will have this course with you students. But now let me tell you about some introduction about these things. Unit testers are those people, usually developers, who test things like function or usually class. They test classes in an object-oriented software. Okay, they test class. And integration testers test a portion of system, for example, a subsystem or things like that. 3, 4, 10 or more classes that work together. Okay, they test these integration of the classes. So the classes will be tested by unit testers, and this integration, this collaboration between the classes will be tested by integration testing. And then when the sub parts of the system, the different portions of the system are tested, then we can proceed to system testing, which is usually a full test of our full software. Okay, the full functional testing of system. And then we have this acceptance testing, which we invite our customers and we ask them, please test the software and see whether it is what you wanted or not. Test the features, test these user interface, test the flows, test everything. These tests are usually used to finalize our contract with the customer, with the organization that has this contract with us to create software for them. Okay, so acceptance testing is for this. An end user, as you all know, is the final users that are going to use our software, and they may provide some feedback about our product, our software, because they're going to use it, and then we can use those feedbacks we receive from our final customers. Okay. These are different levels of software tests, which are usually being used in many projects. In all commercial and industrial projects, we should have these levels of testing. So, is there any question? Is there any questions? Okay, user acceptance testing, UAT. Yes. So, and the stimulus. What is a stimulus in this thing? In this quality attributes. Please read this paragraph. Everyone, please read this paragraph. Dear Mohammed Salim, no, users are not our test tools. We have two things about the users. First, we may invite some users and ask them to please test our software. Okay, for example, now Microsoft, you can join Microsoft Windows Insider program, and you will be delivered with a free version of Windows 11, and then you will test Windows 11 for them. Apple has this program for the newest version of Mac OS, and you can join Apple Insider program, and then you will test the software for them. This is a volunteer act. You can join to different communities and help them to test their softwares, and also you may request for some extra feature, and then they may add that feature to the final product. Okay, this is one kind of using end users for testing. Another one is, you may already know, when you, for example, when you use a program and that program crashes, and then when you relaunch that program, a window will pop up and ask you, do you want to send a report to the, for example, Microsoft, or I don't know, any company that developed software, or even when you have problem with your Windows and it shuts down abnormally, then after it shut down, when you turn on your computer, a window will pop up and ask you, do you want to send a report to Microsoft? This report is your feedback, is the information about that error that caused a failure, and then Microsoft can examine those information to remove these to fix these faults. Okay, so we can use end users in two ways to test our software. Okay, about the stimulus. The stimulus here is our basically is the test that we are executing, different tests, where is automatic test or manual test cases we want to apply on our system. So we can apply them to different levels, such as class, layer, service, complete integration or system, complete implementation of the system, or delivery of system to the customer. This is the final version. Okay, we all know that. This I'm talking about this. So we have different people who runs different levels of testing, which are our stimuluses. Okay, and this is the stimulus. Environment. We may perform these tests, we may receive these stimuluses when we are in design time or in development time or in compile time, integration time, and also in the runtime. As I told you before to Muhammad Salim, when you are using the software and something bad happened to that software, when the information is properly gathered and logged and stored, then you can use those information and send them to the creator company to find the fault. So the environment may be in these stages. Maybe you are in design time, maybe you're in development time, maybe you're in compile time, or you're in integration time, deployment time, or even runtime. Okay, this is our different. These are our different stages of testing, to be more specific. So, what is the artifact, or what are the artifacts that? Okay, do you have any question? I see a student is typing. Is there any question? Guys, do you have any question, any problem? Okay. Artifact. So the portion of the system that is going to be tested is our artifacts. For example, when you are a unit testing, you will test classes. When you perform integration tests, you are working on a module or on a component. Or this, when you use system test, your artifact is the whole system. Or this is the case for acceptance testers or end user testers. Okay, so artifact is the target that we receive those stimulus. What should be our response? The response here is so obvious. We need to look, execute test suite, and capture the result, capture the activity that resulted in fault, and control and monitor the state of the system. These are our requirements, our required responses. Okay, we need these responses. We need that. We need to find those faults. We need to capture the activities that resulted in the fault. This sentence is important. Let me highlight it for you. We need to capture the activities that which are resulted in the fault. Okay. Okay. Is there any question, dear Ali Adel? Okay, so you are translating. Thank you so much. Thank you for your help. Another thing here is our measure. What is the numbers here? How we are going to measure things? How we are going to measure the response? You're asking this for the final exam, dear Muhammad Salim? You're asking for final exam? Dear Muhammad Salim, okay. You know, we ask we don't ask about this table. In the final exam, I give you a problem. For example, I will say we have this system that needs to be testable. What do you suggest to do? What scenarios do you think about, or what tactics do you uh, suggest to use? Okay, this is how we're going to ask questions. So I don't want you to memorize everything in these tables. It's more, I think it's hard for most of the students. So I will ask you. I told you, dear Muhammad Salim, I ask you about a scenario. I say, for example, we need a system for a hospital. We need that system to be testable. What tactics do you suggest? This is a typical question. Or I may say, we need this system to be available. What tactics will you suggest? I need this system to be interoperable. What tactics do you suggest? So I don't ask question about directly about memorizing this table. Don't worry. And the last one here is we need that these testings, these efforts to cover most of our program. Okay, to cover most of our program. And no, dear Muhammad Salim, you ask a question. Why bothering? It's your question. It's not a big deal. You ask a question and I answer you. Okay. So response measure here should be usually the length of longest dependency chain in the test, the amounts of coverage of the software, percentage of the state space coverage. Okay, these are the response measures. For example, let me tell you about a simpler example. For example, you have a program. You have a program written in Python. 10,000. It has 10,000 of lines. 10,000 lines of code. After testing, for example, you may say, I want to see that at least uh, nine 9,900 lines of code to be reached and tested. This is a response measure. For example, you have 10,000 lines of code, and you want that to, after testings, at least 9,900 lines of codes to be covered, to be tested. Okay, this is a response measure. This is what we call response measure. So now I want to ask you to these guys, please review this table from top to bottom. Let me clean it for you. Everyone, please review this table, each part. Thank you. Okay, is there any question? Do you have questions? Okay. So let's look at a sample concrete scenario. You may recall that concrete scenarios will be in this. Concrete scenarios uh, can be obtained from general scenarios. We use general scenarios to write concrete scenarios for our project. So here, let's read this concrete scenario. The unit tester completes a code unit during development and perform a test sequence whose results are captured given 85% path coverage within 3 hours. Okay, so this is a sample concrete scenario regarding testability. Let's discuss the tactics of testability and how we're going to make our software more testable. I think here we need a break, and after break we will return to this slide. Let's have a quick break. Okay. As you may recall, I told you that we have two important things. Let me bring the slide again. When we're talking about testability, we have two important things to worry about, or to be controlling the input. And it means that when we have a system usually has some inputs and some outputs. We know that this is a system has some inputs and some outputs. And when we want to focus on testability, we need to control the inputs and also be able to observe the outputs. Control the inputs and observe the outputs. Okay, these are the two wings of testability. So here, when we want to talk about the tactics of for testability, we have these two important categories. The first category deals with controllability and observability, which this one is about input, this one is about output, controllability and observability. And the second family of tactics here is controlling or limiting the complexity. So limiting the complexity. Okay, limiting the complexity. So let's see these tactics. So let's review this thing here. We have tests that are going to be, excuse me, unit tester, integration tester, system testers, user acceptance testers, or even end users. These tests are going to be executed, and these tactics that we are going to learn, and this is our main target: finding faults. Finding faults. This is so important. We want to. We have these two categories of tactics. I don't know why these slides are not loading properly. Guys, can you see the text on these slides? Can you see the text? Here and here and here. Can you see the text? Because I think it's not showing correctly. Okay, I think it's a problem. It doesn't matter. First, control and observe the system state. I don't know what's happened to the system because it's getting slower and slower. Okay, the simplest form of control and observation and observe is to provide a software component with set of inputs. Let's do its work and then observe the outputs. Okay, it's so rational. We think it's natural, you know. The basic form, the simplest form of the control and observe tactics is to feed the system with some input values, let the system works, let the system to work, and then observe, log, and monitor and study the outputs of the system. Okay, this is the basic form of these tactics. So let me start with the first tactic here: specialized interfaces. Specialized interfaces, you know, when we are going to work with some component, we in some cases we need some special methods to allow the testers to examine these components. For example, many components has a reset method, and when we call this function, this method, guys, I think you know that method is equal to function in object-oriented programming, method or function. When we call this method, report method, the internal state of that component will be resetted to its default values. For example, you all know that when you have problem with your computer, for example, when it is freezed, you can reset that computer. You push a button, or when your tablet or your phone or many other devices are malfunctioning, sometimes you try to reset them, and this resetting usually solves the problem. Okay, so the reset button or reset method, when we talk about software, is a button, is a method, is a function which allows us to set the internal state of the class, the object, to a specific values. For example, when you reset your computer, then everything in your memory, in your random access will be cleared. So the CPU will start from the base that has been designed by the factory. Okay, another method here is, or function here is, report. When you call report, then that component or object will return the full status of the internal status of the object. For example, you know that I think you may have seen that in many repair shops, they connect some computer to your car, and then they press some buttons, and then they can receive a full report of your car about the injection system, about the fuel injection system, about the electrical subsystems. I don't know, about any information that the computer, car's computer has been gathered. Okay, reports method is used to return full state report of that object. Okay, another method here is when that is going to be used in many components, is verbose output. Okay, for example, in Windows, when you are starting your computer in Windows, you see just a shiny logo of Windows, but there are lots of actions that are taking place in your computer as you watch that shiny logo. Okay, but you can push some certain buttons on your keyboard. I don't remember. I think it was F8 or F5 you can click, you can push that buttons, and then the windows will start to report a full report of your system when you are, for example, booting. When the computer boot up, you can press that, I don't know, F8 or F5, and then you can see full reports of your system about what is going on, what is happening in your system. Okay. Usually when we want to repair our Windows, we enable this mode, and then we will get this verbose output. Okay, any questions till now? Let me find a hotkey for Windows. Okay, I think this link may be helpful for anyone who wants to enable this feature window in Mac OS. Command V. Guys, in Mac OS, if you hold Command button plus V at the startup, then the system will enter into verbose output mode. And in the verbose output mode, you will see what's happening in the background when your operating system booting. Okay, so I think you can try this on your computers and see what happens. So now we have the last method here, the last two methods here, set and get. I think that many of you, I think anyone who has experience in programming knows that we have different set and get, or setter and getter methods in objects, because we use them to assign certain values to internal variables of that object. We can use set methods to assign certain values to internal variables of an object. Also, we can use get methods, getter methods, or to read those internal variables. Okay, because as the object-oriented design principles dictates, we cannot access to internal variables of an object. It's not. We can have access to those variables, but it's against the design principle, the object-oriented design principle. So we use these setter and getter methods to allow us to read and write internal variables. To be more specific, important variables of an object or a component. Okay, so this is very important tactic. Each developer should pay strict attention to these important methods when they design their system, they implement their system. They need to implement specific getter, setter methods, report methods, reset methods, and enabling verbose output methods. Okay. Let me tell you about a simple example here. Currently, we are working on a machine learning project in which, when, for example, a user sends a request to the application will start a series of actions. More than 100 of actions usually needs to be completed, and usually the users wouldn't need to see these actions to see the results of each specific action. They want the total and final result. Okay, but the testers, the debuggers need to have access to these actions that are going to take place in the system. So with the system in a way that when the debuggers or testers want to use, they can enable verbal code easily by entering code, and then the system will return full report of each action, and testers can see what's happening in the system. So it will be so useful for them. They can easily find any specific any suspicious command or I don't know, action. Okay, so it's so common to use these methods in this design of your system. Okay, guys, do you have any question? Okay, let's continue. Guys, let me tell you about something. Each student that has seminar with me, seminar course. Some of you took this course with me. Please send a message in WhatsApp. Send a message in WhatsApp to me to add you to a group for seminar students. Okay, to add you to the seminar groups of students. Okay, anyone who took this seminar course with me, please send me a message in WhatsApp and tell me if he wants to have this course with me, guys. If and bear it in mind that if you want to work in Arabic, I encourage you to work with dear Dr. Mehdipur. It doesn't matter that you've taken your course with me. It's not a problem. You can work with Dr. Mehdipur, and he will tell me about your progress, your final score. Uh, but if you want to work in English, if you want to work in English and you know how to uh, I mean, reading and writing basic things in English, and you want to work in English, contact me on the WhatsApp. Otherwise, you should contact Dr. Mehtipur to work in Arabic if you want to work in Arabic. And also, some of students has sent me messages or emails about their final master thesis. Guys, working on thesis, and I have a limited capacity for accepting requests of the students. So I usually pick from students. I usually pick best students I find, and I work with them. So the basic step here is when you work on your seminar and you work good, and you show that you are encouraged, you have this potential to work on your thesis, then we can work together. Okay, so I cannot work with students that I don't know them, they don't have class with me, or they are not active in classes that they have with me, or they don't have seminar with me. I did, basically I can't work with the students who I don't know them for final thesis. Okay, so bear this in mind too, because I saw some students send me a message. It's okay, you can work with me, but we need to have mutual understanding and mutual knowledge about each other. I need to know you. I usually I work with students that I know them according to the class, according to the activities in different courses they have with me. And currently, I'm working with some of good students from Iraq and also from Iran. All of them have been picked up from the best students. I know them from the classes. They are active in class. They work. They try to work on their courses and things like this. So I needed to tell you about this. And thank you, dear students that helped me on translation. I see that you try to translate from English to Arabic, and I appreciate your help. For example, dear Ali Adel and some other students that helped me on this translation thing. I appreciate your kind help. Okay, let's return to this slide. We have another tactic for control and observe system state, which is called record and playback. Record and playback. Okay, you know that, for example, how a sound recorder works. Sound recorder records our sound, and then we can click on or push playback button, and then it will replay our voice, our sound. Okay, this is how the typical sound recorder works. But here, how this record and playback thing can work in a software environment. Basically, we know that each component in our system receives input values. It processes those input values, and then it generates some outputs. Okay, this is the basic thing. Let me draw something here for you. For example, this is my component. Okay, this is my component. I call it component 1, 3, 4. Okay. It's bad. Component number 1, 3, I don't know, 6, for example. Then we have this box around it. So we know that each component receives input values, and it will generates some output values. We all know that. So how, let me complete this image for you, just a second. Inputs and outputs. Okay. Now, how we can record the state of the system? We just need to okay, this color is better. We need to record what is entered into the component. So we need to record these input values. And also, as you know, I told you many times, we have these internal states, internal variables. Okay, we need to, here, these are internal state. Happening. Okay, okay, that's okay. So now, when we talk about record and playback, we just need to record these two things: the internal state and the inputs. So when we want to record the status of system and what is happening, we just need to record the inputs. As a recorder records the inputs of its microphone, we need to record the inputs and also the internal state of each component to enable recording. And the target here is to be able to play the system back and recreate the fault. So you know, all of you heard about something which is called black box in airplanes. Yes, you know that. I know that you have heard about this. Black box. You know what a black box do in airplanes? Black boxes store everything that happens in the airplane, the sensors, yes, the information, dear Asma, the information about the airplane, the sound of cockpit. For example, pilots are talking to each pilot and co-pilot talking to each other. The flight engineer talks. Everything that happens in the air, and also, as dear Asma Sami told, uh, every sensory information. For example, the altitude, the bearing, the speed, the status of different sensors in the airplane, the air pressure. I don't know everything. Why do we need to store all of this information in the black box? Why it is, you know, an airplane crashes, the first thing that the authorities search for is the black box. The police, the military forces, the rescue forces, everyone search for will start to search for the black box. Why this black box is so important? Because when we find the black box, we can know that what happened that caused that fault or the plane crash. Exactly, to know what happened. What happened? Why we don't? Well, why we need to know what happened? Why it's important? Okay, the plane crashed. What is so important about the causes? Because when we know the causes, okay, why, dear Muhammad, why do we need to know what went wrong? Aha, prevention. Exactly right. Uh, why do we know what caused this problem? What caused this crash or failure? Okay. Uh, of course, yes, dear Asma Sami, we need to know the causes of this this catastrophe, because we want to recreate that fault. We want to make other airplanes free of that fault or sequence of faults. Okay, you know, one of the most safest ways to travel is airplane. Airplanes are a lot more safer than bicycles or so safe, so of support, because these severe activities, these strict principles, the airplane makers, the companies, the authorities have, and they want to test. And also they have this special record and playback mechanism, which allows them to play the system back and recreate the fault. Recreate the fault. It's so important. It's so important. Okay, because when we know how this fault has happened, we can make others, other airplanes safer. We can remove this fault. We can improve the other airplanes. Okay, so in any computer systems, not only airplane systems, we need to have this record and playback tactic to capture the information crossing the interfaces of different components and systems, and also for enabling better and higher quality testing, and also creating more reliable products or software systems. So I think you understood this tactic well. If there is any question, I can talk with you about them. Yes, okay, thank you. Guys, do you have any questions? Perfect, thank you. Okay, let's continue. So basically, you guys, let me tell you one more thing about this tactic. Implementing the record and playback tactic is difficult. It's not an easy task to do. It's so hard. It's so difficult in many cases. You know, many commercial applications, the software systems, and generally electronic systems don't have this record and playback tactics. For example, you know, you don't have record playback in your car computer. We have it in airplanes though, but we don't have them in because implementing the record playback is so hard, and in many cases it costs a lot. So we may decide to drop this feature in less critical applications or systems. It's so hard to implement this thing. It's so hard. Just bear it in mind. So let me continue, guys. You know, this control Z, or undo. You know, many of you are using undo and redo actions on your computer. These undo and redo actions are hard too. They are so hard to implement in many cases. Okay, they are not simple as you use them. You're accustomed to using Control Z and Control R or Shift Control Z to redo or Control Z to undo. You use it so much in your daily routines. Yes, you don't even think about it, but it's so hard to implement the Control Z and Control Shift Z in many cases because the sequence of actions are so important. The task hard, but implement them. But bear it in mind, if you want to write, undo and redo for your specific applications, it's so hard. Okay, let me continue. Okay, local state storage. Guys, please read these three items. Read these three items. I let you read them for, I don't know, 1 or 2 minutes, and then I will discuss it. But please read them first. Okay, sorry guys, some thing happened. I need to answer my phone and it took a little bit longer. So localized state storage. You know, in some cases, we need to have some internal or unofficial state storage to let us to test the different states and perform scenario testing and different scenario analysis. Okay, so for example, you know, we want to start our system. Let me change the color. We want to start our system or subsystem or module. I don't want to focus on this. Just start a system in an arbitrary state. Arbitrary state. For example, I want to test what will happen if I try to enter information after a due date to the system. Okay, I need to set the internal state of the system to the due date. And then if I want to add, I can check that if I want to add more information to the system, will the system stops me? Will the system stop me? Will the system prevent this action or not? So I can test, or another example. For example, I wrote a printer driver. Okay, I developed a printer and I developed the driver software for that printer. So now I want to test it. For example, if the print queue, you know, print queue is a memory that the print manager stores different print jobs into that memory, and then when it's pick jobs one by one from this memory, from this queue, and prints those jobs on the paper. Okay, I want to test when this memory is full, what will happen if I try to add some new job to this print queue, to this print buffer, to this print memory. Okay, what will happen if I add if I try to add some more jobs to this print queue? Okay, so to test this, I need a state repository. I need a state repository to, for example, to resemble a printer memory full of information, full of documents, or a print queue full of information. For example, 100, 200, 10, hundreds of pages into the queue, and then I can try to print something more. Okay, so in many cases, we need some state repository to store some specific, some important, some special states in it, and then I will be able to load those states to the system. Okay, many gamers, if you work with the in the games industry, you may have heard, you may have seen this. Many gamers or game testers, I mean, in the industry, okay, they want to test their games, so they need to test specific states. For example, they want to test level 10. Level 10, they want to test everything. They just need to have different repositories of states, and then they load different these states to the memory and test that if the game works perfectly in each state. So this is all localized state storage. I know this concept is hard for some students, that especially those students that have not a programming background. If you haven't programmed a real system, if you haven't worked in a software team, you may have some problems understanding this concept. But first, I'm here to answer your question if you have any question. Second, you can read the book, and you can also search on the internet. So please read and ask me if you have any problems with this concept. Also, there's important thing here. I should mention that we have this choice of granularity. For example, you know that we can store, oh, what happened? We can store different levels of state. We can store CPU state if we are system programmers, or if our software is a system level software, CPU state, or OS. Let me write this in this way: thread state, process state. Okay, these are most common forms of states that we have different granularity. You know that granularity means size here. So this is a very small amount of information. When we talk about state information, CPU state information, we mean some things like processor status word, program counter, stack pointer, and things like this. Usually less than hundreds of bytes. Okay, thread state and process state. Please, if you don't know these terms, I really, really, really encourage you to learn these things. So I write them as homework. Homework, okay? Please study these things. What is CPU state? What is thread state? What is process state? I discussed these concepts with my students in the previous term in advanced operating systems, I believe, as I remember. So you can reach to those documents and ask those students to help them, or you can search online or use any book related to operating systems design. So let's. Do you have any questions, dear Radat Jabbar? Do you have any question about CPU state? Or I don't know. You write it. Why do you wrote it here? Okay. So, is there any question, guys? Do you have any question? Okay, perfect. Dear Ali Adel, this is for your homework. Okay, so do we do the research by yourself? And no, it's good. You are reflect this material in the class. It's okay. It's not a problem. But I want to tell you about this because this will make you distraction, and you will miss this slide. I want to tell you about this. So as I see here, Rada Jabbar is typing, so I will wait for him to complete. Yes, dear Vada Jabbar. CPU state, thread state, and process state is your homework. You can search in your operating system course. Okay. Let me ask you a question. Just a second. Please fill out this form. Are you you are, what happened? Okay, guys, now you can see a poll. Please fill out this form. You are network student or you are software student? Please tell me. IT, information technology, or software engineering student. Okay, I'm waiting for other students. Please fill out this form. You are network or IT student, or you are software engineering student. We need 7 more students. Dear Osama Aziz, dear Salah Ziab, dear Ali Sajil, dear Qasaq Majid, dear Nasr Sader, please. I'm waiting for your answer. Dear Ali Sajil, can you hear me? Or dear Ali Sajil, I don't know, I don't understand. I pronounced it correctly or not. Dear Salah Ziab or Zayab. Please, guys, please answer this question. Dear Osame Aziz, please answer the poll, okay? These students haven't answered yet. What happened? Please, everyone, let me on the note. These students, please answer. Dear Ali Qasem. Okay, it seems that most of you are software engineering students. So I'm asking this because I want to set the next term courses. Okay, so let me tell you about another tactic, and it's enough for today. Guys, are you feeling tired, or we can continue? Guys, are you tired, or we can continue? Okay, dear Ali Adel, how much time do you need? 15 minutes. Okay, we can have your presentation. You can let me give you this Let me give you the permission to use. Now you have permission to use microphone, and now you have presentation rights. So you can start, dear Ali Adel. Dear Ali Adel, can you enable your microphone?
طبعا راح.
Dear Ali Adel, we don't have your voice. I think you have a hardware problem with your microphone, or you need to use some hands-free headphone headset, or you may change to another device. Okay, we don't have your voice. Dear Ali Adel, can you talk? Can you talk?
صوت.
Dear Ali Adel, can you talk, please? For example, tell a sentence.
صوت واضح. صوت نفس الوقت طريقة توفير حلول الأعمال. أنظمة التقييم. والجامعات بشكل فعال لا يزال مقصرا في مجموعة مجالات على المؤسسات التعليمية وإدارة الشركات. أغلب المشتركة عند الطلب. تميكن الموارد والتي تتوفر في الغالب على التكاليف المرتبطة باستهلاك الموارد وتبادل الموارد المشتركة. استخدام خدمات السحابية لا يطلب من العملاء الحصول على تراخيص لمجموعة. كان هناك الكثير من النقاش حول ما إذا كان جمع معلومات في كل صناعة نظرا عن ميزاتها. من الشركات الاستفادة من قدرات الحوسبة السحابية أيضا الاحتفاظ بالتطبيقات السحابية ونماذج الخدمة المناسبة لنوع الشركة بحيث يمكن تقديم خدمة أفضل للمؤسسات ذات الخصائص المختلفة. يجب إنشاء نموذج الخدمة مع وضع احتياجات نوع معين من الأعمال في الاعتبار. تتطلب مؤسسات التعليم العالي نموذج خدمة يمكنها تلبية احتياجات مؤسسات التعليم العالي مثل الكليات والجامعات. تمتلك الحوسبة السحابية الكثير من الإمكانات في المؤسسات التعليمية، ومع ذلك فإن تطوير نموذج خدمة مناسب لمؤسسة تعليمية أمر بالغ الأهمية لجعل الحوسبة السحابية فعالة ومقبولة على نطاق واسع من قبل المؤسسات التعليمية. هناك بلا شك فجوة بحثية يجب سدها، أي فهم واضح لخصائص مؤسسة تعليمية نموذجية معهد تعليم عالي أو جامعة أو كلية، ثم استخدام هذه المعرفة لابتكار وتصميم نموذج خدمة سيكون أكثر ملائمة وفائدة للمؤسسات التعليمية. دور الحوسبة السحابية في الأعمال. تستخدم الشركات تقنية الحوسبة السحابية بقوة من أجل تحقيق الأهداف الاستراتيجية، وكما موضح بالشكل صورة تتحمل بشكل 2، حيث تعد الحوسبة السحابية والحوسبة المتنقلة أمثلة على التكنولوجيا السحابية. ومثل ما عرفنا الحوسبة السحابية المستهلكين التقليدية من خلال توفير زيادة القدرة وفقا للمعايير والتكنولوجيا وضع بشكل طبعا في التعليم لقد غيرت الحوسبة السحابية قطاع التكنولوجيا والمعلومات حيث كان لها تأثير كبير من جوانب الحياة نمت تكنولوجيا المعلومات أبعد من الإدراك البشري الاتصالات والروبوتات الذكاء الاصطناعي سيارات الطيران الصواريخ الخدمات المصرفية والمالية التجارة الإلكترونية وما إلى ذلك. كان لثورة تكنولوجيا المعلومات تأثير كبير على كل جوانب من جوانب المسائل البشرية. تعتبر تقنية المعلومات هي فرع من فروع العلم له تطبيقات في كل مجال وقطاع آخر تقريبا. أصبحت تكنولوجيا المعلومات عنصر أساسي نظرا عن مجال التخصص بعد خدمات تكنولوجيا المعلومات الخدمات والتشغيل السلس للعمليات اليومية والإدارة الفعالة للمؤسسة وتحقيق أهداف العمل المهمة. ضروري الآن للشركات الحفاظ على موارد تكنولوجيا المعلومات الخاصة بها وتشغيلها في جميع الأوقات. بسبب طبعا هاي مجموعة فقرات خاصة بالحوسبة السحابية في الإديوكيشن بسبب التطورات في تكنولوجيا المعلومات شهدت صناعة التعليم العالي في جميع أنحاء العالم تحولا ثوريا خلال العقود الماضية. طبعا واحنا لاحظناها أثناء فترة كورونا حيث أدى تحويل الفصول الدراسية إلى فصول دراسية ذكية وكذلك نشر تقنيات المعلومات والاتصالات المختلفة في مؤسسات التعليم العالي حيث أدى ذلك إلى تغيير وجه التعليم الحديث. كان مطلب مؤسسات التعليم العالي التحول للتعليم هو قضية كبيرة يجب تلبيتها بالتطبيق التكنولوجي المناسب. توسعت تطبيقات السحابة أو الحوسبة السحابية في مؤسسات التعليم العالي بشكل تدريجي على مدى السنوات العديدة الماضية مع وجود عدد كبير من المؤسسات التعليمية التي تستخدم واحدة أو أكثر من الخدمات السحابية. كما لوحظ أن نشر السحابة الخاصة في عدد قليل من المؤسسات التعليم العالي في السنوات الأخيرة. ومع ذلك يجب أن يكون تطبيق السحابة مقبولا من حيث متطلبات المؤسسات التعليمية. تحديات لاعتماد الحوسبة السحابية. بالرغم من الفوائد والوعود العديدة للتكنولوجيا الحوسبة لأن تأمين عقبة كبيرة أخرى أمام تقنية وهي الحاجة للوصول على الإنترنت حيث يعتمد توزيع الخدمات على الإنترنت بسبب نقص توحيد واجهات برمجيات وتقنيات النظام الرئيسي. قد تجد الشركات صعوبة في الانتقال إلى موفري السحابة آخرين. قد يؤدي عدم التوافق إلى ردع الشركات من استخدام تكنولوجيا الحوسبة السحابية. هناك 5 مخاطر سحابية هي مخاطر السياسة، مخاطر التنظيمية، فشل الحوكمة وقضايا قابلية التشغيل البيئي. تصنف مخاوف تسرب البيانات وفقدانها على أنها مخاطر تكنولوجية تشمل الاهتمامات القانونية والمتعلقة بترخيص البرامج وحماية البيانات. يتم تضمين مشاكل البنية التحتية الشبكات وتتعلق الفئة الأخيرة من المخاطر التي تمنع الشركات التكنولوجيا. طبعا احنا مثل ما اخذنا البلوك تشين السحابية هي إحدى هذه القضايا التي تمت مناقشتها مؤخرا بشغف بدقة، ولا يزال هناك الكثير من للبحث والتطوير في المستقبل. تستخدم معظم المؤسسات التعليمية في جميع أنحاء العالم أنظمة إدارة التعلم وأنظمة إدارة المحتوى والشبكات الافتراضية والآلات الافتراضية للتسجيل الصحة والخاصة تعزيز تجربة الطلاب. على الرغم من حقيقة المؤسسات التعليمية والتكنولوجيا التعليمية ودمجها، أن العديد منها لا يزال يقصر في عدد من المجالات. الهدف من هذه الدراسة أو هذا العرض اللي اختاريته أنا هو النظر في تأثير تقنيات الحوسبة السحابية على المؤسسات التعليمية وإدارة الأعمال. أشكركم، آسف إذا أكو إشكالية بالصوت أو الصوت ناصب. Thank you يا دكتور.